Hello everyone, this is Eddie the Magic Monk. Welcome to another complex numbers video. Today we're going to talk about how to multiply and divide two complex numbers that are in polar form. So let's define two complex numbers. Let's do Z1 is equal to R1 cis theta 1, where R1 and theta 1 can just be some sort of number. Okay, so then we have Z2 equals R2 cis theta 2. So an example of that could be Z1 equals 3 cis 20 degrees, and then Z2 could be 4 cis 30 degrees or something like that. Okay, but we'll give you guys an example later on. So basically, if we multiply Z1 and Z2 together, Z1 times Z2 will be equal to R1 R2 cis theta 1 plus theta 2. Okay, that's it. That's how easy it is. So let's do an example of that using some example numbers. So here's an example. Z1 equals 3 cis 20 degrees. So this symbol here is actually degrees, and Z2 equals 4 cis 100 degrees, and what we want to do now is find out what Z1 times Z2 is, and all you have to do is multiply 3 by 4, which will give you 12. So you multiply the magnitude of both complex numbers together, and then you do cis, and then you add together the arguments from both complex numbers, so you have 120 degrees. Now let's check whether this gives us the right answer on the calculator. Now, to check that this is right, we're going to have to convert Z1 and Z2 into standard form and then enter them into GeoGebra. So let's do that. So Z1 is equal to, and as you guys know, 3 cis 20 means the same thing as 3 times cos 20 plus 3 times sine 20 I. Okay, and then Z2 is the same thing as 4 cos 100 plus 4 sine 100 I. Okay, so if you get these numbers, type them into the calculator and then write them out as standard form. So what you're going to get is, so these are your two complex numbers in standard form, and what I'm going to do now is enter them into GeoGebra and then try to multiply them together in GeoGebra and see what the answer is. So in GeoGebra I have Z underscore 1 is equal to 2.82 plus 1.03i, and then I have Z2 is equal to negative 0.69 plus 3.94i, and then I'm gonna do Z3 equals Z1 times Z2. Okay, so I have Z3, which is over here, and I'm gonna draw a line from the origin to Z3, and I want to see what the length of this line is, and it tells me that the length is 12.01, which is very close to 12. Now the reason why it's not exactly 12 is because I have rounded these numbers. So if I didn't round them and I kept them exactly as they are when I enter into GeoGebra, then it'll come up with exactly 12. Now let's look at the angle that this line makes with the positive x-axis. So if I draw a dot somewhere on the positive x-axis and I try to calculate the angle created between this line and the x-axis, it tells me that it is 120 degrees, which is exactly what I calculated before. So this has given us the right answer. Okay, now I'm gonna give you another example and you can see if you can do it. So let's make Z3 is equal to 2 cis negative, I'm gonna give you an angle in radians now, so negative pi over 2, and let's get Z4 is equal to 5 cis pi 3 pi over pi over 2. Actually, let's make it 3 pi over 4. Okay, so try to find Z3 by Z4 and come back when you're done. Okay, so the answer is just 2 times 5, which is 10 cis, and we're gonna go negative pi over 2 plus 3 pi over 4. Okay, so the answer is 10 cis, and I'm gonna multiply both the top and the bottom of this fraction by 2, so the two fractions have the same denominator, and then I can add them together, which will make it 10 cis pi over 4. And I'll just quickly enter these into GeoGebra. Okay, so this is the result after entering it into GeoGebra. So Z3 is sitting at 0 minus 2i. Okay, so if you convert Z3 into standard form, it gives you 0 minus 2i, and Z4 is sitting at negative 3.54 plus 3.54i, and if you multiply Z3 and Z4, you get Z5, and the length of Z5, which I have already calculated, is 10, which matches the magnitude of Z3 by Z4, and the angle that Z5 makes with the horizontal is 0.79 radians, which is the same thing as pi over 4 radians. Since pi is 3.14 divided by 4 is 0.79. Okay, thanks for watching, guys.